Hello everyone. This section we are going to cover section 10.3. This video we are going to talk about section 10.3, applications of quadratic equation. We have 4 examples. We try to focus on the modeling part of the problem. For the solving part, once we have a quadratic equation, how do you solve the equation? I want to maybe give you let yourself to figure that part, because I guess the video is not good if I do over 30 minutes. First example, right triangles. The length of one leg of a right triangle is 10 feet longer than the length of the other leg. If the hypotenuse is 50 feet long, what are the lengths of the two legs? So this problem is about a right triangle. Yeah, what is a right triangle? Look at this one. This is a right triangle. A right triangle has 3 sides, 3 angles, and one angle is 90 degree. Of course, the other 2 angles are going to add up to 90 degree because the 3 angles need to sum as 180 degree. We know that, right? Yeah. So in this right angle triangle, the 2 sides form the 90 degree angle are legs. So from my diagram, the side A is shorter, side B is longer. So we call this is a shorter leg. This is a longer leg. And then the third side, the side opposite to the right angle, that is called hypotenuse. Okay, hypotenuse. And we have a very famous theorem about right angle triangle. That is the Pythagorean theorem. We know in a right angle triangle, with the 2 legs A and B and the hypotenuse C, A squared plus B squared always equals C squared. Alright? So let's go back our problem. We are looking for the length of the 2 legs. Remember the application problem, we always start from finding the goal. You need to have a purpose, right? You get in your car, you need to have a destination in your head. What are the goal? The goal here is to find the length of the 2 legs. Yeah, so this leg and this leg, right? So we are going to only bring in one variable. We're going to bring in one variable x. We're going to bring in one variable x only. And we try to write both legs in terms of x. You give me 1 second, let me turn on the light. It's too dark right now. But I'm not sure will this make it better. So we're gonna bring in one variable x and use x to represent both legs. Well, what a connection between the 2 legs? Let's see the information in the problem. It says the length of one leg is 10 feet longer than the length of the other leg. So what do you think? Huh? Means the longer leg is 10 feet longer than the shorter leg. So would that be more convenient to let x be the shorter leg or be the longer leg? Actually, both work. If you let x be the shorter leg, then the longer leg is going to be x plus 10. If you let x be the longer leg, then the shorter leg is going to be x minus 10. Do you see? They are okay. They both okay. Yeah, your choice, okay? Yeah, in my notes, I use x to represent the shorter leg. then the longer leg is going to be x plus 10. All right? The hypotenuse is 50. That is given. Yeah, hypotenuse is 50. That is given. I label 50 right here. They have the same units, so we don't consider units here. They are all in feet, so that is good. All right, so what do you think we're going to do next step? Now we have a right angle triangle. Hypotenuse is 50. The shorter leg is x. The longer leg is x plus 10. Our goal is to find the length for both legs. We have both legs in terms of x already. If we could solve for x, if we could find the value for x, then we would know the length of the two legs, right? In order to solve for x, we need to have an equation. One variable, we need one equation. Yeah, how do we set up that equation? Remember the Pythagorean theorem? Yes, we're going to apply the theorem to set up that equation. Shorter leg square plus longer leg square. Longer leg is x plus 10, right? So you put x plus 10 in the parentheses equals hypotenuse 50 to the power of 2. 50 to the power of 2 is 2500. On the left-hand side, here if you FOIL this part, you would have x squared plus 10x plus 10x plus 100. Combine like terms, you have 20x. And remember, I said I leave this for yourself to figure out. And you can apply the solving by factoring method to have the two solutions. One solution is 30, 30. The other solution is negative 40. We have to get rid of the negative 40 because this is an application problem. Okay? X is assigned as a meaning. X here represents the length of the shorter leg of the right angle triangle. It cannot be negative. So we get rid of that one. Then we keep x equals 30. So if the shorter leg is 30, then the longer leg is 40. 10 feet long. 10 feet longer. 10 feet longer. Yeah. So the two legs are 30 and 40. I think the modeling part is clear here. All right? All right. So example 2. Example 2 is a physics problem. Let's read the problem. Launching a rocket. A rocket is fired straight up from the ground with an initial velocity of 640 feet per second. Using the formula h equals negative 13 t squared. Yeah, so this is a very important information. H equals negative 16 t squared plus v sub 0 t plus h sub 0. To determine the following, we have two parts, A and B. A, when will the projectile hit the ground? B, when will the projectile be 1200 feet above the ground? Round answers to nearest hundredth. All right, so let's see. We have this function. This actually is a function, okay, everybody? Yeah. So this actually is a function. On the left-hand side of the equation, we have h, the height of the projectile. On the right-hand side, that is a function in t. T here is an independent variable. Because when you fire a projectile, the height of the projectile depends on the time. So as I said, this is a function actually. The independent variable is t, time, in second. The dependent variable is the height of the projectile. And other things, v sub 0, h sub 0, they are actually constants, okay? Yeah, be aware of that. They are actually constant. So let's see. The part A, when will the projectile hit the ground? Yeah, what does that mean? hit the ground. Hit the ground means h equals 0, right? So this actually is a quadratic function. The graph of a quadratic function is a parabola. But this is not the path. By the way, this is not the path of the projectile, okay? This is just the similar with the function, the graph of this function. Before we actually go ahead to figure out the time when the projectile hit the ground, we want to think about the values of v sub 0 and h sub 0. What does that mean? H sub 0, if you let t be 0 here, in this function, if you let t be 0, means initially, originally, as the very beginning. Okay? As the very beginning, as t equals 0, the height as t equals 0, h equals h sub 0, right? The height of the projectile is h sub 0. We know that you are firing the projectile straight up from the ground, so h sub 0 actually equals 0. Initially, the projectile is on the ground. The height of the projectile equals 0. So as t equals 0, we know h equals 0, which make h sub 0 equals 0. You know what I'm saying? Yeah, that's how do we know this part, h sub 0 equals 0. Yeah, there is some work we need to do before we go ahead to work on part A and part B. Because in this function, value of v sub 0 and h sub 0 is not given directly. It's given indirectly. Yeah, as we just did, we figured out h sub 0 equals 0, right? All right, what about v sub 0? Turns out v sub 0 actually is the initial velocity. V sub 0 is the initial velocity. Okay, velocity. If you have the chance to take a calculus, you can take the derivative of the function. You would know why v sub 0 here is initial velocity. So I would say this part might be difficult because you might not know or identify the v sub 0 here means initial velocity. Okay? Yeah, that might be difficult for you to figure out. But actually v sub 0 here is the initial velocity. We know that the initial velocity is 640 feet per second. So the value of v sub 0 is 640. So then the function actually becomes h equals negative 16 t squared plus 640 t plus 0. Okay, so that's going to be the new function. That's the new function. Okay, that's the new function. I remember I'm able to move this part, no? Maybe this way. Yeah, okay. So this is the function actually. Let me highlight in the same color. All right. Okay, so part A. Now we need to figure out the time as the projectile hit the ground. When the projectile hit the ground, what's the height? Height is 0, right? So you make h be 0. You would have 0 equals negative 16 t squared plus 640 t. And now you are looking at a quadratic equation. You solve this equation. In my note, I applied the factoring method. I have either t equals 0 or t equals 40. I get rid of the t equals 0 because we know hit the ground means after the projectile going up and reach the maximum height and then going down and then hit the ground. It's not gonna be 0 second, right? Yeah, 40 seconds is the time for the rocket to hit the ground, to go back the Earth. Part B, when will the projectile be 1,200 feet above the ground? So we simply just evaluate h as 1,200. Plug 1,200. We'll substitute 1,200 for h in the equation. And you are looking at a quadratic equation again here. Okay? And I have the solving part in my note. And turns out we have two irrational solutions. And you use your calculator to convert them to decimals. So there are 2 times the projectile reached the height 1,200 feet. That makes perfect sense. You see the projectile go up, right? And the first time it reaches 1,200 feet is 1.97 seconds. And then keep going, reach the maximum and then go down. And the second time, it reached the same height, 1,200 feet, is 38.03 seconds. Does that make sense? Yeah. Take your time to understand the modeling part, understand the function, this function, and why do we make h be 0 in part A, and why do we make h be 1,200 in part B. And try the solution, solving the equation part on your own. All right. So let's look at example 3. Example 3 is a geometry problem. A rectangle is inscribed in a circle. So I have the diagram here. So you see the circle is outside, the rectangle is inside. The 4 vertices of the rectangle happen to be on the circle. That is called inscribed in a circle, such that each corner of the rectangle lies on the circle. If the length of the rectangle is 10, yeah, this 10, I labeled it here. Let me highlight it, pink. Yeah, the length of the rectangle is 10, and the width of the rectangle is 6. Yeah, it's given also. What is the area and the circumference of the circle? Use pi as 3.14. Pi is an irrational number. Yeah, this is supposed to be approximately equal to. Yeah, use pi as 3.14. So that's how do we round it. Please round your answer to the nearest hundredth. All right, so how do we find the area and the circumference of the circle? So we need to be very clear about the goal here, okay? We have 2 things to figure out about the circle. The first thing is the area of the circle. This is the formula for finding area of a circle. A equals pi r squared. R here is the radius of the circle. And the second thing we need to figure out is the circumference. Circumference formula for a circle, C stands for circumference, equals pi d. D here is the diameter. Do you guys remember I said that how did we find the pi? Pi is circumference over d, over diameter. Remember the story. And then no matter what size of the circle, people found out the quotient of the circumference of the circle and the diameter of the circle is a constant. And a constant is not a rational. Is a irrational number. Is not repeating, non-repeating, non-terminating decimal. Okay, all right. So that's the formula. So in order to find the area and the circumference for the circle, we need to know the radius for area and the diameter for circumference. Do we know the connection between diameter and the circumference? Diameter is twice, what connection between diameter and the radius? Diameter is twice of radius, okay? The radius is the distance between the center of the circle and any point on the circle. Twice of the radius is the diameter. So do you see this line segment in red? That is the diameter, okay? That's the diameter. So if you look at this yellow triangle, the yellow triangle is a right angle triangle. The two legs are 6 and 10. Hypotenuse is D. D is the diameter of the circle. So by the Pythagorean theorem, yes, we're going to use that theorem again. We are able to find a value for D. Turns out value of D is a irrational number. So you have D squared equals 10 squared plus 6 squared, which is 136. What method you apply here? Square root property. Square root property, you have D equals plus or minus square root of 136. Of course, you're going to get rid of the negative value because diameter cannot be negative, right? So D is going to be the positive square root of 136. And in chapter 9, we have learned how do we simplify a radical. This is a square root. Yeah, we have learned how do we simplify a square root. We have the simplified form of the diameter equals 2 times square root of 34. I'm going to leave that for you to figure out. I try to make the video within 30 minutes for the quality. Okay, so the diameter is given, is found out, is ready. The diameter is 2 times square root of 34. Radius is half of it, is a positive square root of 34, right? And then you're going to plug in radius here to compute the area. You're going to plug in diameter here to evaluate the circumference of the circle. Yeah, those computation part, I'm going to leave that for yourself to figure out. The modeling part, how do we understand the diagram, and those variables, what those variables represent. I think I made it clear. Last one, example 4. Cost per person. The women in a bridge club are to travel to a bridge tournament by bus for a total cost of $1,980, which is to be divided equally among the women. However, 2 women became ill and could not make the trip. The cost to the remaining members increased by $11 each. Of course, if you have more people to share the cost, each person pay less. If you have less people to share the cost, each people gonna pay more. How many members made the trip? Okay, that's the goal. Let me highlight it. How many members made the trip? That's the first part. Second part, what was the final cost per member? Yeah, so let's don't rush the second part. Let's figure out the first part first. So now our goal is how many members made the trip. I would bring in a variable n. You can use x if you want. The reason I use n in this case, because the number of members is going to be a whole number. So I use n to remind myself. The variable here is a whole number, is not a decimal or fraction. You cannot go half of a person, right? Or one quarter of a person. So look at the 2 blue parts. Look at the 2 blue parts. Okay, what's still gonna charge you the same amount of money? They don't care how many people go. The total cost for the bus to make the trip, that's the $1,980, right? Same amount of money. They don't care how many people go. The total cost for the bus to make the trip, that's the $1,980, right? So if we divide $1,980 by n plus 2, n plus 2, remember, is the number of members in the club. Then do you agree that that number is the cost per person? Cost per person, I'm going to write CPP. Cost per person before and after, okay? Before, like originally they planned to, they all go, right? Before the two people got sick, yeah, before. So $1,880, the total cost, divided by the total number of members in the club, that is the cost per person before. And then let's look at this blue part, $1,980 over n. The total cost divided by n. What is n? N is the number of members eventually made the trip without those two people got sick. So that is the cost per person after the two people got sick, right? Yeah, so let's take time to understand the two quantities. $1,980 over n plus 2. That's the cost per person before the two people got sick. And $1,880 over n, that's the cost per person after the two people got sick. Okay, so now I'm gonna let you to tell me which number is bigger, which number is smaller. They have the two blue parts, okay? The two blue parts, which quantity is bigger, which one is smaller? Remember, this is CPP, cost per person after. That is a cost per person before. So this after the two people got sick, the total member, the members went to the trip is less. Then each person gonna share more. Do you see what I'm saying? Okay. Yeah. After the two people got sick, $11 more. That's given. Read the problem. That is given. $11 more. So we have 19. Let me change the color. So we have 1980 over n equals 1980 over n plus 2 is the modeling part. It is an apartment like $800 a month. If you are the only person pay the rent, then you pay $100. You pay $800 every month. But if you got a roommate, then cost per person would be $400. You see what I'm saying? So more people to share the cost. Cost per person is smaller. Yeah. So in connection between the two per person before, this is the cost per person after. This is bigger than that. How many bigger? $11 bigger. So that's